30 centimeter, 20 centimeter drilling. So this, let me take this is height H2. And there's a hole. At height 10 centimeter. Density of liquid rho 2. This is rho 1. And it is placed on what? Rough surface. Any conditions will come. Normal contact will act. The weight of the liquid 1. W2 will act. Here velocity of efflux V will come. Now a thrust force will act. So this thrust force, I'll show it here. Now how the friction? If at all, if surface on which vessel is placed is smooth, then a rightward force of magnitude 3 Newton is to be applied on vessel to maintain its static equilibrium. I don't know. Let's see that. The first option A is what I'm checking. What external force I should apply. For that, we should know velocity of efflux. No? What is the expression for velocity of efflux? V is equal to root of 2G H1 plus H2 by 2. Will I agree? Because 10 centimeter, 20 centimeter. Because the hole is exactly located off at middle level of the second liquid. So this will be 2G. H1 is how much? 30 centimeters, so 0.3. This will be 0.1, 0.4, 0.448. So root 8 or 2 root 2 meter per second. Then what is the force? Thrust force should be equal to density of liquid rho 2, area of cross section A, V square. Density of the second liquid is how much? 1200. Area of cross section of the hole, 5 centimeters square. So 5 into 10 to the power of -4. It's a calculation based. We have to work out with calculations. So this will be 2 root 2 whole square. 0.6 into 2 root 2 whole square will be 8. 8 6 are 48, 4.8 Newton. There's a thrust force. Then how much of frictional force I should apply? 4.8 Newton is what I should apply. 3 Newton is what is telling. So there's a wrong statement. For equilibrium of cylinder, F external should be equal to F thrust. So therefore, how much of force I should apply? 4.8 Newton. Fine. Now, if the surface on which vessel is placed is smooth, then no force is needed to maintain it in static equilibrium. No, wrong statement. No, you can see thrust force will act here. If you remove this external force, so what will happen to the container? Due to thrust force will accelerate. No, so therefore this B will be wrong statement. Try to analyze. See, your fluid mechanics is over velocity of efflux. The rest all everything is mechanics side here. So if this is smooth, we are discussing condition for smooth here. If the surface on which vessel is placed is smooth, then no force is needed to maintain its static equilibrium. We need some external force, no? Then it can be in equilibrium. So option B is wrong. No, if the surface on which vessel is placed is rough, then the minimum force needed to apply on vessel to maintain its static equilibrium is 0. Okay, let's see that. What is the mu(s) value? The same diagram. No need to change anything. Just we have to take the same diagram. No. In what action? If at all friction acting, the friction will act in this direction. Why friction should act towards right? Because thrust force is acting towards left. So what is the expression for friction now? Limiting friction will calculate, or the normal reaction first will calculate. What is the normal reaction? Normal reaction should be equal to rho 1, rho 1 A H1 G, rho 2 A H2 G. Density of the liquids rho 1 600, area of cross section 100 centimeter 1000 into 10 to power of 4, H1 0.3 into 10 plus rho 2 200. Anybody give value of n? One 180 plus 24, 240. Check it.
Yes, sir.
420.
420 Newton. Okay, this much is what? N1 value. So we know mu equal to 0.04. Let's calculate the limiting friction. Mu n. So mu is 0.04 into 420. Anybody value? FL?
So on 16.8, sir.
16.8. Yeah. 16.8 Newton is the limiting friction. How much of thrust force is acting? Yeah, fine. 16.8. How much of thrust force is acting? 4.8 Newton thrust force is. Look at this. But how much of limiting friction is there? 16.8. So what is the minimum force needed? 0, no. I need not to apply. Go back to friction idea. The thrust force is 4.8 Newton. Limiting friction is how much? 16.8 Newton. So therefore, what is the friction acting? Will be static. And what is the minimum force needed? Will be 0. So this will be correct statement. Now maximum force. What do you mean by maximum force? So the maximum force idea will come like this. Now why I should bring maximum force? So what is the F minimum needed? Will be 0. No, option D will check it. So definitely what will happen? I should apply force. This is external. What is the maximum external force I can apply? It should be equal to Ft plus Fl. We know thrust force is how much? 4.8 Newton. Limiting friction 16.8.
21.6, sir.
21.6 Newton. I'll make it. So I agreed, no? So some ideas of friction, I think nothing big. Just we should be very careful. Observation is needed. The two liquids, they don't mix up each other. That's a basic condition. So always have that idea, the emerging liquid will exert a force. You can use what is there. Let's go for next one.